Number 9, right? So, iceberg. If iceberg is floating on the river, so let's say the total volume of the iceberg is V. And the submerged volume, let's say it's V submerged. Actually, you want to find out the fraction. Is this fraction of the submerged volume or floating?
The fraction that's above.
But anyway, if you find the ratio of this with this, you can find the fraction right here. But you can see what is the relationship to relate this submerged volume and this volume. This one is in floating. So the weight of the iceberg should balance the buoyant force. The weight of the iceberg is mg equals to rho ice multiplied by V total multiplied by G. M equals to rho V, right? The buoyant force equals to rho water. V submerged multiplied by G. So V equals to 2. You can see you are going to get these two equal to each other. So if you rewrite this equation, you can see the ratio of the volume is actually can be calculated from the ratio of the density. That's why you get that ratio of the density. Okay. But it's from the force analysis.
So any kind of buoyancy problem that talks about
it's equilibrium. So the buoyant force has to be the same as the weight. And the weight is the density of the ice multiplied by the total volume.
So how would you...
the buoyant force is the density of the water multiplied by the submerged volume.
So how would you calculate the volume? Because it's not like a fixed object. I mean, it's the iceberg, so it's not a specific shape.
Okay, but here is so that's the point. You want to know the volume ratio. You're not going to directly measure it. You calculate the density ratio.
You get a percentage.
Okay.
You will get the percentage, and you will get the fraction. Okay. So what it means that you get V submerged divided by V total. You are going to get so V submerged divided by V total rho ice over rho water, right? So you are going to get some percentage. Whatever. Suppose it's 80%. Then the fraction above the water should be 20%. Right? So something like that.
Simple.
Yeah.
Okay. So I'm guessing almost always with buoyancy, when you're asking for that, we're always going to end up with this rho v equals rho v.
Just for any object, yeah. If it's float on the surface, you always have this kind of. So you can see, in terms of the ratio, if you have very light object, it may float like this. Okay. If you have quite heavy object, but still less heavier than water, it may float like that. So you can see the submerged ratio is actually determined by the ratio of the object and the water. And if this one is larger than water, it will sink down. Because even completely submerged, it cannot provide enough buoyant force.
Makes sense. I was trying to solve for the wrong thing. Because like I got the same formula like that when I started doing it by myself. But then I was like, well, how do you solve for volume if you don't?
You were thinking volume as in
I was
like
thinking volume. Yeah, I was thinking volume as two unknowns, and I was like, well, shit, let's do it.
I got you.
Yeah, so I got
Yeah, no, I could see how you get confused though, because it's not like a lot of questions actually ask for ratio.